of this class. Okay, so we started how to express, how to define formal grammar, okay, and regular expression. Now see, okay. So what you came to know yesterday that regular expressions are used to represent certain sets of strings in an algebraic fashion. Okay, so and we use regular expression in order to represent our strings in any language in algebraic fashion. Okay, so you have to learn the rules about regular expression. Now I'm sharing. Okay, uh, I'm sharing. Is my screen visible? Why not the PPT is coming? Okay, so you may see that. Okay, you may see that there were some rules. Okay, some rules are based on the union. The union of two regular expressions is also a regular expression. Okay, and the concatenation of two regular expression is also a regular expression. Okay, that is expressed in R1 comma R2. Now next will be like the iteration. Okay, the iteration of a regular expression, that is also called closure of regular expression. So closure of RE means regular expression. I'm writing like RE. So closure of regular expression is also a regular expression. It's also a regular expression. Now, why? What does it mean? It means that if we get closer of R, so let R is a regular, capital R is a regular expression. This is called this is called closure of regular expression. Okay, this is called closure of regular expression. Now, what does it mean? So this is also a regular expression. Now let us have this symbol R star. Okay, so let's take any symbol A and we have closure of A. We can express closure of A like this A star. So this means everything that we can form with A. So closure of A means we can form everything that with small a. Okay, so that means A star may contain all the form that we can get from small a, this symbol. So it consists of null, a, 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 okay, like this. So all the form of a is called a star or closure of a. Okay, so this is called closure. So I may write here closure of small a. Now next one. So this is the rule number 4. So yesterday I told you three rules. Now the fifth rule is the regular expression over the set of inputs are precisely those obtained recursively by the application of the previous above rules. So that means using the previous four rules, whatever the regular expression we get over the input, all the terminal symbols. Okay, so these are nothing but the say those we obtained recursively by application of the previous four rules. Okay, several times. So that means these, these, this concatenation, closure. Okay, this all form in the rule number 5. So that means what says rule number 5? It says that the regular expression over the set of terminals sigma only sigma, these are nothing but these are precisely obtained, you may write it recursively by the application of all the previous rules. Once on several time. Okay. Okay.
ম্যাম
So now we can take, yeah. Have all.
ম্যাম বলছিলাম যে অনেকে এন্ট্রি নিতে যাচ্ছে মানে ঢুকতে পারছে না ক্লাসে, মানে একসেপ্ট করুন
Why?
ওদেরকে।
Whatever. Okay, I will admit them. See, during once the class started, okay, I cannot go back every time or will admit. Okay, so please tell them to join earlier at the class.
ওকে ম্যাম।
Okay, so it is not possible every time when I start sharing the screen. It's not possible every time go back to the meet and to admit you all. Okay, I give you 5 minutes to join. Okay, now let's take examples. Okay, so these are the five rules, and now we have to take and see the examples over regular expressions. So now some examples of regular expression given sets. So describe the following sets as regular expression. Now I'm writing here. These are the some examples. See, if I write 0, comma 1, comma 2 in this set. So now we have a set of consisting 0, 1, 2. Okay, now what are the symbol of this set contains? The symbols that set contains. Okay, symbol that set contains. What are the symbols here? 0, 0, 1, and 2. Okay, so we may say that 0 or 1 or 2. Okay, so what will be the regular expression for this set? The regular expression for this set, that this set may take 0, either 0 or 1 or 2. Okay, so I may write 0 or 1 or 2. So regular expression, let expressed by r. If I say this, the symbol is r, then r will be 0 or 1 or 2. So how to write 0 or 1 or 2? We use the symbol plus symbol, 0 or 1 or 2. So that means here in this regular expression, when I use this plus symbol, it denotes here or. Okay, the meaning or. So this is one example. So this is very simple example. I just start to give a few examples. Now number two, another examples, the set of null. So now here what is the no, there is no symbol like null. I'm writing. Okay. Okay, so I write null. So if you see the null symbol, tell me here. Just wait.
Hello, ma'am.
Okay, can you see my screen?
यस मैम मैम एक्चुअली मैम प्रेम का नेटवर्क चला गया था मैम तो वो इन नहीं हो पा रहा है
अभी
मैम
ओके उस अभी एंटर हुआ.
यस मैम
Okay, say another example, null and AB. Okay, AB. So now see, in this set we have two symbol null comma AB. So when in this example we have an empty symbol there, so in the previous example you have seen that there was no empty symbol. Okay, so remember this, that when we have no empty symbol, there are the only symbols belong to set is any one item, 0 or 1 or 2. But in this case there is an empty symbol, that is null symbol. So that means we can say that our regular expression is R and it contains uh, a null concatenation of null and AB. Okay, so it is denoted as concatenation of null and AB. So no plus operator or symbol is used here because null symbol are with this set. So when we have null symbol with this set, so we cannot write plus symbol or symbol. In the previous example, we have seen that there was not any empty symbol or null symbol. So we can use this plus symbol to denote or. But when there is, sorry, no null symbol, then we can just write like this. That means concatenation of null and AB. Okay, so another example, that is set of A, B, B, A, comma B, comma B, B, A. Okay, so here see there is no null symbol, so we can say that ABB or A or B or BBA. So we can here use plus symbol. Okay, so that means ABB or A, comma B, comma BBA. Okay, so that means that without null symbol we can take any one. Okay, or, so or is denoted by plus. So all right, so now we come to another example where I can put uh, null symbol and also like 0 comma 0 0 comma 0 0 0 comma, and like this. So if you look carefully, we can find any string that are formed by any number of 0 together. Understand? So we have null in this example 4. We have null symbol in this example 4. Along with we have any number of zeros that are put together. Okay, now it is called closure of 0. It is called closure of 0 because we can form any string with 0, any number of zeros we can put together. So how do you denote closure? Now in the previous example you have seen that with the symbol star. So we can denote closure of 0 with star. So it is called closure. Okay. So in closure of 0 we find this empty symbol. Okay, so that means it starts with empty symbol and can be formed with any number of zeros together. Okay, so this asterisk symbol denotes closure. This asterisk symbol denotes closure. So now in another example, if you see that there is a set of 1 comma 1 1. Okay, so we have here uh, any string that can be formed with using the symbol 1. Can you see that here we can have any number of string that can be formed with symbol 1. Okay, so here we can use any number of 1. So it looks like closure of 1, isn't it? But there is a difference. See, in case of or in order to form closure of some symbol, we must use the null symbol. But here, it looks like closure of 1, but there is no null symbol here. That means null symbol is not present. Okay, is absent here. So here we may write it is not asterisk, rather plus. Okay. So if I write this, so any closure without the null, it is called closure of one or closure of that symbol excluding empty symbol, excluding empty symbol. So you may write it is 1 plus. Okay. So that means it is without the empty symbol null. Okay. So these are the three rules of regular expression. Now, in case of expressing regular expression, we have to use some identities. We have some identities of regular expression. What are those identities? So now we will see some identities of regular expression. Okay. So here, uh, in case of expressing identities, we use one symbol, that is phi. This is also denotes an empty set. Okay, not symbol, empty set. What is this? Phi. Okay, wait. So now the first identity is here, phi plus r. So what is r? Let's text and a symbol r which denotes regular expression. So phi plus r equals to r. So what does it mean? You write here, তোমাদের কাছে কপি থাকলে you must write here phi denotes an empty set and r denotes a regular expression. So what does it mean? This plus symbol between two sets denotes union. Okay, it denotes union. Union operation between an empty set and a regular expression always produces another regular expression. Okay, so this is the union operation. Next identities is concatenation. So what, how you express concatenation? We can express our concatenation of two regular expression by just putting them together. Okay, so phi r, concatenation of phi r and plus r phi. So that means concatenation of union of these two concatenation. This symbol denotes union. So union between these two concatenation, okay, by taking union of concatenation phi r and r phi is nothing but to get an empty set phi. So you write here that concatenation between phi and r, okay, and r concatenation phi always perform or always get another empty set phi after performing an union operation. Okay, so here what is this concatenation? Okay, so it is called union operation of phi concatenation r and r concatenation phi. Okay, gates and phi. So these identities you must remember, because we have to use this or apply these identities to uh, prove some regular expression. So next identity is using epsilon. Now what is epsilon? Epsilon is also used to represent the null move. Okay, so in case of NFA, we may see that in case of any move where we denote by epsilon, okay, so that is also denote null. So what is epsilon? Small e. Now I'm searching the symbol epsilon in here. Yes, I got. Okay. So in this case, let me write concatenation of epsilon and r. So it is called epsilon concatenation r. It is nothing but same as r concatenation epsilon. So that means if we perform concatenation of epsilon and r and vice versa, okay, that remains same. So it is concatenation of epsilon and r. Okay. Next identities. Okay. Any next is that closure of epsilon. Okay. So what happen if we take closure of epsilon? Okay. So our identity says that closure of epsilon is also an epsilon. And number five. Okay, is this one you have already seen in the rules? The union of two regular expression is if we perform union of the same regular expression, we get the same regular expression again. Okay, if we take closure of a regular expression in another identities, R asterisk, that means closure of R. Okay. So if we take R asterisk, that produces closure of same regular expression. So here asterisk means closure. So there are lots of identities. R closure of R. So union of R and closure of R is nothing but union of closure of R and R. So next one is if I get closure of R, closure of R, what we get? Nothing but closure of R. Okay, we don't need to prove them that how it get. Uh, this one. Number 9. Okay, this one is important, that epsilon plus r star. So that means union of epsilon and union of epsilon, between epsilon and r, closure of r. If we do this, then it is nothing but epsilon plus. Now what is r star? What is r asterisk? What is r star? It is nothing but r closure star r. That means closure of r and r. So you write it, closure of r and r. And now what is how we get this from this one? Okay, from this identities number 7. Okay, so it is closure of r. Okay, in these identities it is says that epsilon plus, that means union of epsilon and r star is r star. So like this we have, I am giving you here some few number of identities, and later I will provide more identities. So if we know this or remember this few identities very clearly, then we can see that how we can prove using identities of regular expression. Okay, so there is our one theorem in your syllabus. There is one theorem in your syllabus, Arden's theorem. Okay, Arden's theorem. Okay, it will take more time of writing every equation using Word or PPT. Okay, আমি তোমাদের আর্ডেন্স থিওরেমের স্টেটমেন্টটা পাঠিয়ে দিচ্ছি গ্রুপে। Okay, so what does it say? That in Arden's theorem, we take two regular expression P and Q. Let we have P and Q are two regular expressions. Sorry, over sigma. Okay, over sigma. Okay, so we have two regular expression P and Q over sigma, and if P does not contain epsilon, if P does not contain epsilon, then what Arden's theorem says? Then Arden's theorem says that following equation, the following equation in the regular expression, another regular expression are. So we have P and Q, two regular expression. And among them, if we consider that P does not contain any epsilon symbol. Okay. Any empty symbol is not there. Then the another regular expression is there, r. So our Arden's theorem says that the following equation are given by r equals to q plus rp. So there is a regular expression r, and using r we have an equation r equals to q plus rp. So this equation has a unique solution, has a unique solution. That means Arden's theorem says that r has a equation r equals to q and p. This is the equation, and this equation must be solved. This equation can be solved, and can be solved by using one and only a unique solution. No other solution, only one unique solution, that is, what is the solution? R equals to qp star. So here unique solution means only one solution of this equation exists. That is, we have to prove by Arden's theorem. We have to show that this solution is R equals to QP star. Okay, I'm giving you because I have no time to write all the steps using word. It will take more time. So I'm providing you the solution. Then I can explain you. Just wait and check your group of formal language automata. I am giving you the solution. Okay. So please check your WhatsApp group. Please check your WhatsApp group that you can see that uh, when the Arden's theorem says that you will get uh, one unique solution of R equals to Q plus RP. So in this case, you can replace it with one solution R equals to QP star. Okay, so according to Arden's theorem, we have to prove that this one solution exists, one and only solution exists. Okay, so if you get this picture of the solution, you can see that in the first line, I have written that I have started by taking R equals to Q plus RP. So take, this is our equation number 1. Okay. Now from this I can write what I can write. So for replacing this, we have to check our identities that I have shown you. So Q plus RP. So instead of R, we can replace R equals to QP star. Now, so Arden's theorem says that this is our solution. So here we can replace R equals to QP star. Okay. So now if you replace R by QP star, what you will get? QP star P. Okay, so instead of R, we replace R by QP star. Why? Because in our Arden's theorem, it is given. We have to prove it. Okay. So now in the next case, we can reduce it by taking common q. So after taking common q inside the bracket, we will get 1 plus q is taking out. So we get p star p. Okay. Now p star p is what? It is an identity. Okay. So if you see that p star, now if you see p as r and regular expression, so এখানে দেখো আমরা কি করেছি, what is this, see in this identity, epsilon plus r star equals to epsilon plus r star r. Okay. Okay, that is nothing but r star. So এই জিনিসটাই আমরা এখানে অ্যাপ্লাই করব. So if you apply this, and consider p as r, okay, p ke r হিসাবে consider করো, okay, then you can see that this is epsilon plus p star. How we get p star? Okay. Okay, how we get p star? So if you consider p as r, then how you get p star? Here. Okay, so r star is epsilon plus r star r. Okay, so here instead of this, okay, you just write here, this is whole thing as p star, because we are replacing p by r here. Okay, and following this identity, we can write this is as p star by identity 9. Okay, so now in this case, it is asked that r equals to q plus rp has a unique solution this. Now this is taken as the equation, and we get the solution r equals to qp star. Okay, hence it is proved, but it is not the full part of the theorem. We have another part, second part. Second part is what, that is stating that this is the only solution, unique solution. So it is given in the picture that r equals to q plus rp, this is given in the question. So instead of r, you replace r by q plus rp in the second line. Okay. So how we get? You get after taking out the bracket, q equals to multiply করে দাও p দিয়ে qp plus rp square. So we have again r in our equation. So we have replaced r by q plus rp, but we again get r in our equation. So we again replace r by q plus rp. So we are continuously replacing r. Okay, again we are taking out the bracket and multiply, we get q plus qp plus qp square plus rp cube. So if we continue this, we can get equation after n times, that q plus qp plus qp square, so on. So ultimately we get plus qp to the power n. After n times, we repeat the steps. And in the last line, if you see the copy, the picture, rp cube. So here we write rp to the power n plus 1. Because in the second last term, you can see that qp square and the last term rp cube. So in the second last term, the power is n minus 1. Okay, and in the last term, it is in the second last term, if you take n, then the last term will be n plus 1. Okay, so if you observe this line, and then you can replace r equals to qp star, which is stated as the unique solution. So ultimately, you can replace r equals to qp star and taking out the q common, and inside the bracket you get one epsilon. So you know that including epsilon, what we get? The closure of p, so qp star. So r equals to qp star, it is the only solution. Okay, so this is the thing you check. Okay, uh, I'm giving you the Google form. Giving you the the
मैम नेक्स्ट क्लास का लिंक दे दिए मैम देवीमित्रा मैम।
ओके ओके, तुम लोग ज्वाइन कर दो और मैंने वो गूगल फॉर्म का लिंक दे दूंगी।
ओके मैम।